is Oracle architecture. Here in this sessions, actually I'm going to demonstrate you what is the actual Oracle components, what is Oracle instance, logical and physical structure of Oracle database, a process structure, memory structures, and how that instances get ready when database is actually started. Now let's start with Oracle architectural components. We see in this diagram Oracle database and instance. So it is known as Oracle server. Oracle server is a combination of Oracle database and instance. Database is a physical part that is consists of many physical data files in the form of binary, and whereas instance is a loaded part, or it is a means to access a database. When we start a database, it is automatically this instance gets loaded into the memory, and then user can connect to the database, or DBA can access that database. And the database is made up of granules. In instance is a combination of system global area and background processes. HG is a system global area or shared global area, you can say, where this part is useful when users fire some queries, and the background processes that make the communication with memory structure and with the database. So it acts intermediary between your components part and the database physical part. Hello?
Yeah.
Yeah. Okay. Now this part is loaded, and let's say suppose any users fire some query, how it is going to be processed into the Oracle instance. This database part is actually on the hard disk. It consists of the 3 files known as data file, control file, and log file. Whereas this 3 files is very important, or we can say these files are integrated, they are related to each other. The control file maintain the relationship, and it is contain the information about database. When it is a crucial file for database, we can say if the file is not working, it might be more or one or more file required to operate a database. It consists of database information, or we can say metadata about the database. And as in this square bracket, we can in yellow part we say these 3 files are integrated. Control file maintain the integrity between data file and log file, or it made information about this. And there are other files like parameter files, password file, and archive log file. Whereas this parameter file are configurations file, these are required to configure memory structure that can be dynamically configured or statically configured. Before starting the database, this file could be used, or there are 2 types of file like a initialization file, text file, and parameter file. So there, this file is generally for the configuration when we do have to configure some components or size of the instance, or we can say HGA, and the other granular parts of that. Whereas a control in parameter file, there are a lot of information, or we could do dynamically by using alter system command and like by SP file. So SP file is a binary file that can be automatically detected by at the time of database startup. Whereas relog file is also a group file. The database should have 1 or more group file that maintain the current status and activity what is going on in database. It is going to be logged into the log files. Archive log files, whereas in physical database they are apart from database. Archive log file is used to general purpose of is media recovery, and password file is used to authenticate database administration, because by defaultly when database is installed on administrator as a username and password, so administrator could log into directly with database without a password. To protect or give security, that only DB should log in, so password file is useful. Okay, let's start with the logical part as an instance. Okay, when like this, when database is started, instances get ready, or is this a logical part, and it is loaded into the memory. And let's say the background processes and memory structure get loaded, as well as server process get loaded over there. Now, when user puts username and password, and he tries to fire some commands like any SQL commands over there, then user process gets started. Then it sends a user process on the client side. It sends some request to the server process, and what is exactly server process on the server side is, server process is responsible for checking status in database, like we could say username and password. It would check into the database and then make the connection with instance. It not directly get connected to database. It's connect to through the instance, and then its interaction is going to be happen with background processes in database. These files are binary, that is actually managed by some processes, some background processes and server processes. So we could say instance is actually a combination of memory structure and process structure. The process structure means there are different type of processes, like we could say these are the background processes, server processes, user processes were there. The processes is a program in database that is responsible for having some activity that could do with database. For example, they are categorized like background, as I said, background process, server process. The task of server process is exactly to validate user's name and password and interact with a physical database to retrieve data from the database into the shared pool. And whereas background process interact with physically. We'll go by one. Let's take one example. Suppose this shared HG is a system global area or shared global area. It is made up of into the granules. When user process some command, let's say select star from some DML, DQL, DDL commands, the server process first of all check the statement it put into the shared pool. The name indicate shared pool is a shared memory area where in multi-server or multi-user environment, all the things, statements or the data that is retrieved or privileges that is going to be shared. Let's say some user fired command like select star from table name. Then server process would check whether that its statement is going to be stored into the library cache. Let's say select star from EMP, and then the server process would check whether that statement already been there. If it is there, so it is going to be counted. And then the data dictionary parts is going to be checked where the rights for the that statements or user who has actually fired that command. Whether that user has a rights on that objects, what objects here are going to be retrieved from the database. When it is checked, then has a right, then server process read data from the data file and put into the block in the database buffer cache. Okay, this is going to be happen similarly for the number of multiple users those are connected, right? So this is a job of server process to retrieve database from the database and give the final result to the user process. Okay, but that I'll let you know how it is going to be happen, the connections for that. Let's say one by one we'll go for before that the shared pool, library cache, data dictionary cache, database buffer cache, and read log buffer. So these are the fundamental components of Oracle instance. These are the compulsory fundamental, and there are also other options are there. Other granular part like Java pool, large pool, they are optional. The shared pool components or memory area is generally, as name indicate, it is just shared. So number of statement is going to be shared, and it's make the performance of the database queries. Queries get stored over here, like number of user firing, then the library can actually get the hits or that number of hits, and it is going to be managed by LRU. This recently used algorithms. And when data is going to be retrieved from by a server process, it stores into the database buffer cache in the form of blocks. And whatever the changes happen to the block, that is going to be maintained, and it is reflected into the log buffer. The purpose of read log buffer is to get the recovery for instance recovery, or after that we could do media recovery with the help of read log files, and that is going to be archived over there. That's we discuss later on. Okay, so these are the just a brief overview of a component. Then let's say we'll go deep in step by step. Then let's say what is exactly Oracle server, and that let's say explain what is exactly Oracle instance is that. As I explained, it is a medium, or it is a medium access to the database. Without instance, user cannot access a database. It should be ready. It should be in an open state. Then user can connect with database and do their transactions. For one database, we have only one instance, but multiple instances also possible. But in RDBMS, we have only one instance for our database. And in rack environment, we could have more than one instance on the different nodes. For our database, we have only one database and one instance. It consists of memory structure and background processor. Now, how the connection, as I said, the user fires some commands and get connected to the database. How exactly process is going to be happen? This thing is establishing a connection and creating sessions. So what exactly is going to be happen between this user process, server process, and how connection is going to be created? This diagram says how connection is established. The connection is only between user process and server process, not directly to the instance. We could say when user put username and password, user process sent to the server process, then server process checks whether that user is registered with database or not. And if it is registered, then connection is going to be established. So user process allocate a server processor for that connection or session. And after, once a connection is established, user could fire a commands that we can say insert, update, delete with related to the database. Then actual session is started. Session means what? When user connects and it's starting some commands like transaction, like let's say DML, DDL, and then that is a session for that particular user. For one user could have multiple sessions over there. Let's say example for how connection is established and the session is exactly what is connection and session. I'll differentiate between. Let's say if I'm calling to you, I dial, first of all I dial your number on my phone. When I starting dialing a number, that means when I press a calling button, it starts calling for it start means from the my mobile side, user process gets started and it broadcasts number to the network. Then when it's if I find that it is a ringing, that means server process and your side, that is connection is going to be established. So ringing means what exactly? The connection is established. And when do you receive the phone, that means session is started when you say hello and hi. This is exactly the connection establishment and session. Session is actually a communication or doing the transaction with database that server process will do with directly with instance, and connection is just to making validations and connecting to allocate a server process over there. So this is a scenario with establishing a connection and creating a session. Let's say if Scott or any HR user tries to connect with database, he first tries username and password, then this process will fetch that data from the client and sends to the server. The server process is find whether that user is registered with database. If it is registered over there, then connection is established. So this is a establishment of connections. And after, once it's valid, a user fires some commands, let's say DQL, DDL, DML, whatever, then the session is created. So that is exactly the establishing a connection and creating a session. Okay. Hello.
Yeah. Yeah, Kailash.
Yeah. Is there any question from your side?
No, Kailash.
Is there any question from your side?
No. No.
Okay. Now, what is exactly, as I explained, what is the Oracle database? It's a collection of the data that is treated as event. Data means exactly, we could say here a physical file, data file, control file, and log file. Where it's in diagram, it says the data file it is growing in size. That means actual data of database goes into the data file, and that is actually growing. Whereas control file not grows as more, and the redo log files are grouped. They are in cyclic fashion, so whose size as a more is not recommended for the database. So it could reduce the database performance, and that structure in the recycle fashion. So we'll get later on. It is not actually the total explanation of architecture. And there is arclog file, as I said, for recovery purpose, media recovery. For example, let's say any of the database files get corrupted, that we could DBA can recover from the arclog file. So from the at the start of database, if we do have some backups and arclog file available, then we could do any kind of recovery over there. So in place recovery or past in time recovery also possible. And so the consist of 3 files. These are important. Means it is a crucial for a database, data file, control file, and log file. So these are required to operate. But at least control file and data file of a current status should be required. And if a log file is not there, at least we could start in past in time, and we could use a database over there. So these 3 files are very crucial. Whereas if any of corruption is happened in this file, so they are not crucial for database. Without that one, we could start, or manually we could create parameter file or password file, and then we could start a database, because our actual data is stored in Oracle database that are operational, not in other files. The physical structure. Just a minute. Okay. The physical structure of the database, it consists of 3 header, data file, control file, and log file. If you see in the diagram, data file has a header. Header has a special purpose. It says exactly like act as an index as how blocks are stored in the data file, and that it is a going size, and other files don't have the header over there. So that is main purpose of header in database data files over there. A memory structure. Sorry. Oracle memory structure is consisted of system global area and program global area. So this area is allocated at instance startup and is fundamental, as I explained. It is also known as shared global area. It is shared among the number of user processes or session. Program global area allocated when the server process is started. So when a connection, as I said in last diagram, here, okay, user process, and when user connect to the server process, as soon as it is connected, so PJ is going to be allocated for that user. And there are different PJ for different users, but a common instance for all users. PJ is different. If let's say a Scott is connected, and then HR is going to be connected. So there are 2 different PJs for every user. So the PJ is dedicated for every user, and instance is common. That is a shared global, as the name indicates. Okay. Now what is exactly memory structure? As I said, HG and PJ. Now what is HG exactly? A shared or system global area, that is a get loaded in the part when database start, or at DBA could start manually. The HG consists of several components that I said: shared pool, database buffer, cache, log buffer, and other structures over there. And there other is large pool and Java pool. I'll explain one by one what are there. When it is crucial, it is mandatory to set some size for the Oracle instance over there, or HGA. So HGA is a dynamic and size using by HGA maximum size, or we could do with we could check what is the HGA max size over there by connecting as the DBA. Now I'm going to connect my system as the Oracle DBA, and let's say my database is already started over here. Let's connect a DBA. Here I'm not authorized with a password file, so I could connect directly with system admin as a DBA. SQL plus say no log. I'll connect first of all. No log means just I reach to the SQL environment without any without any started database or not connected to the database. If I say show user, it says nothing over there. I didn't connect it to database yet, but just I reached to SQL environment store. Now let's say if I want to connect without any password or without any authorization or without password file, so I could put sys as sysdba. Now it's connected. Now password file has been configured, so system admin could log in over there. As I explained, the password file is very important. Suppose I log into the administrator and database is stored in administrator or any other users. In this case, system administrator could log into the database if no password has been given for the DBA. Now let's say the database is started and the instance is ready, and we could check what are the parameters of the XAMAX size. So XAMAX size is actually size for the total granules that is available in XA. Show parameters, you could see by using the SP file, that is binary file, those parameter has been configured already. Show parameters. Show parameter XA max, or we could say XA just %. It shows XA max size or %. It will likely match what are remaining characters over there. XA max size is about 1 GB, and this 1 GB is shared between the granules or components available in our instance structures. This one. This actually size for this parameter, like XGA max size. So these parameters are shared this side, whatever the 1 GB are shared for these components over there. So AG is the dynamic and size using XG max size. So as I said, how to see and view, we can configure with parameter files. Let's say statically I could say show you so what is the location of that parameter file where we could set parameter before starting database, but it get affected in our instance when we do restart the database. So making changes into a database, it need to restart database.
So, Kailash, this SGA max is allocated for each instance separately?
Yeah, SGA is for different instances.
So you have multiple instances, then that means from physical RAM, you have for each instance 1 GB, 1 GB. If there are 2 instances, then it will be 2 GB. Is that right?
But means it is on different nodes, no? Instance is going to be loaded on different nodes. It is a rack, because I need to study for that more. But in one system, how do we could start 2 instances?
Sorry, I couldn't hear you.
So actually, it should be on different nodes.
Different machines.
Different node or different systems. So database could be on one CPU, we could say, but whose instance can be loaded on different system nodes.
Okay.
The static parameter, I'll let you know that where exactly we put the parameter files. There is it will be stored. My database is actually on app administrator up to date. I'm sorry, sample files are there. Let's see the P file. I'll just rename it over. So this is a sample file where you could find some parameters list, and I'll open from this notepad. So as I said, I'll search for HGA. Sorry. I think it is not specified over there. Okay, it is just a sample file where we could put some, if we want to have from at the startup or manually, so we could copy paste this one, or it can change, and we could say from here also at the time of startup. We can say HGA system global area size here. And you can say Okay, so like that we can configure, and this should be affected when I restart the database with the data heap profile. So this is different as compared to our architectural component that it's required more session to go for that one. Let's continue for the next one. Also, continuous virtual, once memory is allocated by FJ max size, as contiguous memory allocation like it is in a granules. It is a consecutive. The size of all these granules is based on FJ max size. Let's say once we specified 1 GB of size for that granules like HGA, the shared pool database buffer cache and log buffer and other pools, they share this 1 GB of memory, but there are some dynamic components over there. They automatically, their size will depend upon not exactly the HGA target. That is a new concept that is used for automatic granule management or memory management of that. So shared pool, let's say shared pool requirement, let's say 3 MB, database buffer 2 MB, but it is not is in use. Database buffer only using 1 MB though, so 1 MB is in wastage. So that can be reallocated to the other granules if it is needed over there. So that is exactly if the target is set. So dynamically components are managed. So that parameter also we could do for a memory tuning part. That this shared pool, database buffer cache, ruler buffer, and large pool come across over there. Large pool is for backup and recovery purpose. So they could dynamically resize automatically as needed accordingly workloading, whatever the processing is happening for that granule. Okay, so now the shared pool, let's say how it will be configured with the parameter files, or also with SPF file we could do dynamic configuration of this. Shared pool is what exactly, as I given a little bit brief explanation about that. The shared pool is used to store the most recently executed SQL statement and the most recently used data definition. So SQL statement and data definition is what exactly? Let's say, as I said, select star from update or anything. Our SQL statement is exactly goes in library caching, and the rights for that one, whether that who is going to be for that command, what are the rights are given on that command. It is going to be checked into the data dictionary. So data dictionary is a metadata. It checks the rights, availability of table, and we can say a parsing activity exactly goes in data dictionary. So it's check exactly how statement is going to be executed. The statement checks if a select star from EMP. It checks first of all. The table is available in database or not. So that is one of the rights. And then who is firing that commands, and he has rights on that or not. Okay, so this is the actually data dictionary components based on that. A data dictionary also consists information about database and rights of users, how many users are registered in database, what rights on they have, constant information, and everything goes in data dictionary. Library cache is to just to store SQL statement, and as I said, they are used by LRE. So it consists of key performance related memory structure, library cache, and data dictionary, and their uses I had explained you. And its size is determined by the shared pool size. So let's say what is our shared pool size over there. We could say check from the show parameters. I'm sorry, spelling mistakes. Show parameters. So sorry. Yeah, so parameter is so shared. Okay, so here we could say shared pool size is 0 because it is automatically managed over there. So it is shows 0 when XG target is specified. So in that case, it required automatically the size is going to be managed over there. Okay. So if you want to set a manually size for that, we could do with commands. alter system command can be used to set dynamically size of that. So we could change by using alter system, set schedule size, let's say alter system set shared underscore full underscore size equals to, let's say 64, whatever is given. So what is the mistake? So 64 mega.
I think the shared spelling is wrong.
Yes, let me take it again. Yes, yeah, sorry, I'm sorry. Shared full simplified store 64 and okay, and the 5 parameters. Shared okay. So now it should be 64 megabytes as been dynamically set. Now library cache. The library cache store information about the most recently used SQL and PLSQ statement and in the library cache. When we do fire some commands, that actually it's stored into the library cache, and library cache actually SQL statement goes stored over there, and it's enable the sharing of commonly used statement like shared pool, as the name indicate. A number of commands get shared, but depending upon the rights. That shared pool is managed by the algorithm is known as least recently used algorithm. That least recently algorithm is exactly how much duration that statement would return into the shared pool. So it's determined by least recently used algorithm. Least recently used algorithm is find data. So those are most recently used statement that goes to the top of in a, we can say, library cache. So that is stays in memory as long as a number of hits come across for the statement. Let's say update statement has been fired 5 times, and that the hits is more. One statement hits 4 times, then 3 times, and like this. The most recently used statement managed according to the LRA. Hit is 3 times, then after 2 times and 1 time. And those statements are not more in use in library cache, so that they goes out of the memory. So that are not used mostly. So that is a least recently used the algorithm manages that on the statement that are not mostly used, that goes out of the memory depending upon the size and the use of a statement. So it consists of two structure area, shared SQL area and shared PLSQL area. So it is a part of library cache where SQL statement stores, and in PLSQL area, PLSQL blocks get stored on that. Has its size is depend on the shared pool size itself. Library cache and dictionary cache has their sizes automatically managed depending upon the shared pool size. What I already configured 64 is depend. Yeah, how much size is depending on these two areas, two granular SQL and PLSQL areas over there. Now data dictionary cache, the next components where actually store blocks. The modified blocks come across, or when server process read data from the database file, and the server process actually stored in database buffer cache, and that what exactly other things database buffer will do. The data dictionary cache is the collection of the most recently definition. I'm sorry. That is a database. It is a database buffer cache. So it checks the writes The data dictionary cache is a collection of the most recently used definition in the database. So it stores, as I said, constraint information, table information, user information, and all database information goes into the data dictionary. It includes information about, let's say, privileges, columns, indexes, and so on. During the parse phase, the server process look at the data dictionary for information to resolve object, name, and validate access. Means, if new user login into the database, first of all, the server process will check whether that user has been registered on in database. So it is going to be checked into the data dictionary cache. So data dictionary cache has a logical structure or some use as there that is managed by server process would read that and check it whether that user has rights on that objects from which table user exactly fetching the data and so on. So it's generally for the access. Catching the data dictionary information into memory improves response time on a queries. Means what? Every time it's this data dictionary also is managed by LRU. Whatever the components or the data writes are stored into database buffer, data dictionary cache. So if let's say I fired a command select star from, and again I am refiring that same command. So at that time, writes would not going to be checked. So it's into the performance. Only it checks because already I am validated. Then it's into the performance of not rechecking the constant and rechecking the writes and this. Size is determined. Its size also depend upon the data shared pool. Now the database buffer cache. Database buffer cache is actually it is a store a modified block over there. That modified block or that user block, it comes from the server process read from the database and store over there. But when it comes across over there, the database buffer cache store copies of data block that have been data from the data file. So server, when a request comes to the server process read that data from the particular data file and store that blocks in the form of block into the database buffer cache. So to storing, what is exactly used to store that block here is make the performance. Let's say it enable great performance gain when you obtain and update the data. So once a data is ready, suppose let's say a multi-user environment, I fired a command like select star from table, and somebody wants to update some statement from that table. In that case, what happens? That users is only validated by writes, and server process would not read data from database because already a block has been in database buffer cache. So that would make a performance of that. Only writes are going to be checked into database buffer cache, and the statement is that hits is going to be more. Let's say I previously hit that statement 2 times. New user comes for that, whose hits is becoming now that who is again hitting same statement. It's become 3, and only writes for that users are checked whether he has the rights or not in the data dictionary, and then he gets data blocks directly from database buffer cache, not from the database. So reading from the physical devices require more time as in memory. So it would make a performance. So that's the database buffer cache user currently. Now next thing is that how much time or how much durations or what are the criteria to store the blocks in database buffer cache. So actually it's written it is going to be managed by LRU, least recently used algorithm, as a shared pool. The block those are mostly recently used, it remain into database buffer cache, and those are not mostly used, so it goes out of the database buffer cache. So the most is the database block size. So it is determined by as a database creation time, and we could say what is exactly our block size of a database. We could see by using so DB block size, let's say show parameters. The block is the smallest unit in database. There are different type of physical block and logical block. Server process read that from the physical data file in the form of block and store into buffer cache. Show parameters. DB block size. So you could get block size is 8 kilobytes over there. So DB block size is 8 kilobytes. So it is remain fixed. So we could not change this database block size once configured. So for my database, it is 8 kilobytes. So its size is varies depending upon the scenario: 8K, 16K, 32K, and 64K. There are different cache sizes. Okay, consist of independent sub caches. DB cache size. So it exactly says what are the cache size over there. So number of times we are the blocks come into the database buffer that are selected from the database. Now it says DB cache size actually says the what are the size of database buffer cache. Then DB keep cache size. So the blocks that is likely to be available, how much time it is going to be kept into the buffer cache. That is our sub caches or the caches are there. And recycle size cache. So it's says that how many times that block can be reused on database. We could set size of database buffer cache by using DB cache size, or let's check. So what is our actually DB cache size over there? DB cache size. So show parameters. DB percent. I'm sorry. Session terminal and this one. DB underscore. Yeah. So DB cache size. So it is as I said, it depends upon the size of your target. So these are automatically managed. The size is 0, so it is automatically managed. So if you want to set that manually, we could do similarly. Previously, I set some granules. Auto system DB cache size we could set a 90 megabytes. So DB cache advice is actually beyond this scope. So it is required for the tuning purpose. So you could get advice on to gather statistics. So gathering statistics on memory components is very important to tune the database performance. So in that case, DB cache advice is required, and we could set by using commands like alter system, or we would do for parameter file levels DB cache size advice. So tuning purpose. More important is tuning how much memory, what advice could it be given for the different components. So we could have some advisors for tuning the memory components like shell pool, Java pool, database buffer cache, and so on. Now next component granule is a relog buffer. So importance of relog buffer, as said, it is mainly purpose is instance recovery, or it could be used for the media recovery depending upon relog files and that. So how do we do exactly use a relog buffer cache and make availability of database like recovery at the time of recovery, how it could be useful. Relog buffer cache and it records all changes made into the database buffer cache. So whatever the block is changes, as soon as change happens, it is going to be reflect same copy into the relog buffer. So the purpose is to recover, because any block is going to be corrupted, or any transactions or any records is corrupted from database. So we could do recover from the relog buffer folder. So the other processes is responsible for doing recovery for that. So let I know that how the recovery is done. Its primary purpose is recovery, as I said. So its recovery would happen automatically when system starts highlighting that scenario, exactly the relog buffer. Changes recorded within are called redo entries. Whatever the changes made in database buffer cache is automatically reflected into the relog, that is a copy sent to some. So that is called recorded within the redo. It's known as redo entries over there. Redo entry contain information to reconstruct the redo changes. So we could reconstruct changes made into the database buffer cache. So main purpose is to recovery, and size is determined by log buffer. So we could do that using a log buffer. So let's say what is the size over there. So parameters. So log parameters. So it is a log buffer. Log. I'm sorry. So log buffer is its value has been settled over there. Okay. Now next, large pool. The main purpose of relog buffer is also, let's say, I'll explain a little bit example of relog buffer. You come across the relog file, so that is the better. It will be better at the time of relog file management. Large pool. This is large pool is an optional. As I said at the architectural explanation time, explanation of the architectural component. At that time, I explained large pool uses exactly what I said. For it is a relieve the burden placed on the shared pool. Let's say there are a number of statements coming in shared pool. So when we configure large pool, the large pool it can be configured with alter system command dynamically, or we could do with sp file or that. It releases a burden placed on exactly shared pool. So that is one of these. And one use of a large pool is for backup and recovery. So it could be configured when we do have a backup and recovery operations in our database, or there are large numbers of users in database. In that case, you could configure a large pool as well. Generally, large pool also could be set at a nightly basis. When we do have a backup and recovery for organizations database, in that case, we could set database in we could set large pool to relieve burden on shared pool also, if number and if there is a backup and recovery things are happening in organization. So it is better to configure large pool. So that it make a little performance, or we can say a performance of database. So it separates our task. If we don't have large pool, so if we perform in backup and recovery, it would take help of shared pool, and the shared pool, as we said, so it is shared for the processing part, and the backup and recovery is happening in shared pool. So definitely it will degrade the performance of database. So DBA recommends whenever a backup and recovery happens, the large pool is configured. Let's say it relieves the burden placed on the shared pool, as we know that, as I explained. The configuration memory array is for the session memory, slave and backup and restore operation, as I explained. So when you are in shared server environment, it is better to configure a large pool. Unlike the shared pool, the large pool does not use an LR release, so it would not perform any algorithm to manage the in like a block how it is going to be stored. LR is not applied for large pool, and its size is determined by large pool size, or we could do large pool size is we could configure by with the alter system command, and large pool size as well, as we did some configuration commands over there. Next one is a Java pool. Similarly, it's required. Let's say we do have some application application that is already written into Java with our Oracle database. In that case, it is recommended to have Java pool should be configured over there. A Java pool service is the parsing requirement for the Java commands. Let's say we have some JDBC connection with Java with Oracle database. In that case, this the processing of the JDBC commands related to the database, it processed, or it get executed or get processed into the Java tool. So it's required if installing and using the Java, we have some Java application and connection with JDBC database. In that case, it is required. It is stored much as the same way in PLE skill in database table. So PLE skill table is like it is an array. We could say it is like a similar kind of things, or we can say collection kind of things over there. That is a PLE skill table. So it is sized by the Java pool size, or we could do alter system commands, and from the parameter file we could set that, or we could check show parameter Java pool size and so on. Now a program global area, it gets allocated, as I said in architecture, it's allocated by server processes. Now what is exactly use of PGA, program global area, we could say, or process global area? It is a memory area that allocated by server process when user try to connect with database. And each user process has, or each user connected to the database, they have their separate PGAs over there. The PG is a memory reserved for each user process, and that connected to the database. So there are two types of PGAs over there. One is for dedicated server, and one is a shared server. Let's say we have one user and one server process. In that case, we could say it is a dedicated server. Dedicated server means exactly one server process having one user process having one server process. Let's say if for our database 3 users want to connect. In that case, if we do have 3 processes for allocated for every user, then we said they are dedicated. And for 3 users, if we do have only one server process that is shared among between the 3 users, then we could say that is a shared server. Shared server means exactly the shared server process, not exactly our database. We could say that it is the database instance could get shared with the help of these shared processes, server processes. The server process is a main component between user process and instance. So that could serve a services generated that could serve requests generated by user processes and fulfill the call generated from the user processes and retrieve data and do some transaction in database and fulfill the requirement. Now, when we do have dedicated server, in that case, our stack space is exactly the session information is whatever the transaction user performs. So that is exactly the session. So from the beginning of a login, from the time of login to the end of the logout time. So in that case, what users performs the transaction. So that is exactly the session from the beginning to end. Session information is stored into outside of HGA. Okay, and the sort area cursor information. Sort area means what is required for the query sorting. Cursor information is a private area that is used to process a SQL statement. And when in shared server, we do have shared server configured. The sort area cursor information are stored outside the AGI, but session information goes to in shared global area or system global area. So these are the PGA and 2 types of PGA, dedicated and shared. Now the most important part is process structure. As we know that what is a process? We could say a process is a program that is responsible for doing some tasks or operations. So there are, as said, a different type of processes are there: server process, user process, and background processes. Background process is responsible for having interaction with your memory component, let's say HG and physical database. So that do the most of the interaction between all that. So Oracle database is Oracle server process is a program that depends upon the type can request information, execute series of steps, or perform the specific tasks. So these are the program, they are specified a specific task, they do accordingly specification. Let's say user process, responsibility of user process is that started, and a job of user process is to fetch username and password and send it to the server process. So server process job is to connect to the Oracle instance and is started when a user establishes session. So server process took that username and password or any queries and fulfill that request generated from the user process. It search into database or table name or whatever. Likewise, it will also check writes in the database dictionary cache. So this is exactly job of server process: fetch data from the database and put into the database buffer cache. Background processes, it's available when instance is started and a communication between memory components and physical database. Now let's start how user process and server process get interact with each other. A user process is a program that requests interaction with Oracle server. So means we cannot, when we do connect with database, we cannot directly connect with instance. There is an intermediate process, like a server process, which it fulfills call generated from the user process. So let's say how it must first establish a connection. When do we want to connect with database instance? Our connection goes through server process. So when we put username and password, it goes to the server process. Let's say I put username and password and press enter. Now it says the server connection is established. So a request is going to be sent to the server process. Server process will check in database username and password. and after that at fetch username and password is right, so that then it is get connected. So we could say it does not interact directly with the Oracle server. Means server is not user process is not directly with Oracle server. Oracle server is a physical and logical structure. That is the server exactly. So exactly our connection is not happen with instance. So connection happens with server process. Means server process is allocated for your user process, and then you could do transaction with a database. So that is a user process. Now after that, server process, what it does? A server process is a program that is reside on a database server, and it's always ready to waiting for incoming from the user side. So it fulfills call generator and return the result. So it connection, it processes the statement, export statement, and gives the result back to the user process. Or that can be dedicated or shared server, as I explained in PJ part. It could be shared or it could be dedicated for each user process. Now, a background processes. A database has a background processes. There are some of the mandatory background process maintain relationship between a logical memory part and physical database. There are mandatory background processes like database writer, more number of processes over there as indicates. Process monitor, checkpoint, log writer, system monitor, and recovery, and other optional background processes. But in this session, I'll explain a mandatory background processes over there. So what are the importance and uses, when do they, how do they interact with database part, physically and logical memory components. Now let's say a very database writer process, a first process that we are going to be look into the database buffer cache. Database buffer cache, what are the modified block? As I say, a dirty block or modified block means what called a dirty block. Those are mostly modified in database buffer cache. So database writer to the data file. So when exactly, so database writer writes to data file. So here data file exactly consists of our data in the form of block physically on our hard disk. So server process would read that data and put into the database buffer cache. But whatever operations is happening in database, like the modification of data and everything, it happens in database buffer cache. And depending upon the situation, when these blocks get to be written in data file, so it is depend upon these rules or this situation, these points, when checkpoints occur. Okay, let's say our checkpoints is a status that occurs sometimes in database. Let's say lock switches occur. Okay, or manually we could do the checkpoints. So that is one of the event generated in database. In that case, database writer would write a modified block from database buffer cache to the data file. Second point, dirty buffer threshold reached. Dirty buffer threshold means what exactly? So there are limits are specified for this modification block in database buffer cache. If that reached over there, so database write what is the mostly modified block, that is a threshold value has been reached over there, database writer automatically writes to the data file. Third one is no free buffer, means there is the size is so let's say suddenly a more block is generated and that is not a sufficient buffer is free, database buffer cache is not free. In that case, what are already available blocks, a modified block that get written by database writer to data. Timeout. Let's say we didn't satisfy these points or these events, and let's say there is only one block has been modified, so it is not like the checkpoint not occurred, that is buffer threshold is not reached, no free buffer, but there already let's say 99% buffer is free and only block is there, and there is no still any transaction is happening in database. In that case, a timeout occurs. So there is no any interaction is happening and there is little timeout. When the timeout occurs, it's write a modified block to the database writer. So sorry, database writer write to data file. A rack ping request, when we have multiple instances on different node. In that case, if we ping for same database, if we ping a different nodes for that, that is a I'm sorry, that is a ping request over there, and then it gets what are the buffer from that particular instance, a database buffer caching, it gets returned to sorry, it's get right to database writer, write that modified block to data files. When tablespace offline, a tablespace is a logical storage structure. Actually, it's map relationship between physical. It's mapping between a physical data file and logical structures actually. So tablespace is a different topic or different scenario where database actually is managed in the form of tablespaces. Different tablespaces or one tablespace is associated with multiple data files. So when we do have offline of a tablespace, we do offline for backup and recovery management purpose. And in that case, we could do offline of a tablespace. In that case, if we do offline of that, database buffer writer writes to. When we do tablespace read only, when we truncate or drop a table, the data is going to whatever in modified block, it is get returned to the data files. And when we do start backup of a tablespace associated with a number of data files, when we do have backup of data files, we could backup the files. We could backup, and then database writer writes a block from data buffer cache to data files. Now let's next log writer is very important of background processes. In diagram we could say when actually the log buffer writes a block from relog buffer to the relog file. So relog file use, as I say, for the recovery. We could do recovery. Instance recovery is the most important of use. Relog files and media recovery also. We go later on what is exactly how media recovery is happening with relog and arclog files. What are the modified blocks from the database buffer cache are that are reflected as it is copy up into relog buffer, and then relog buffer writes to the relog buffer write data the blocks from the log writer writes data or block modified into the log buffer to log files at a commit. When commit occurs, exactly the modified blocks are get returned to relog files, whereas database writer would not write commit to the data file because it is very lazy algorithm. The log writer also writes when one third of this size is get full, there is a 1 MB of redo, then log writer writes, and every 3 seconds it writes a modified block to the log file. And before database writer writes, when a database writer writes, so whatever the block in a copy of a block that is already available in the log file that writes to the log file server. So this is the use of the log buffer, and purpose of the log file is recovery. We could say instance recovery also, and whatever the changes from this events at this point, we could say every changes made into the database that's going to be tracked into the log buffer, and so we could do a recovery in future any corruptions is happening in database with suitable backup available. So this is a job of the log files. And log writers having the specification, these events, this is task of log writer, and actually it's write in cyclic fashions to the log file. So we have that separate topic how log writer and the log file works differently. Now S1 is very important process for that. The very mandatory background process. Responsibility of S1 is what? Main purpose is instance recovery, and the main purpose is instance recovery. Suppose let's say we are in progress of the transaction. Let's say my database is working and I'm doing some transaction, but it's required some time to be reflected into database. Let's say first of all let's check get example of ATM machine. If you insert some your ATM card into ATM machine, at that time let's say you have a balance available and you are withdrawing some money. As soon as you are trying to withdraw some money, at that time you have balance 5,000 rupees, and if you try to withdraw 2,000 rupees, you get 2,000 rupees. Just as soon as you get the money, let's say server get down. To reflect this transaction withdrawn of your transaction, it will require some time to reflect into the original database server, or we can say bank server.
In that case, your balance would be 5,000, but it will not reflect as a 3,000. Why? The server goes down immediately as soon as you withdraw some money from the ATM machine. In that case, a bank would be in loss. So the transactions would not reflect into the database. So your if there is not happen any recovery, let's say you had been withdrawal some 2,000 rupees from your account, actual balance is 5,000. In that case, bank would be in loss and you would be informed that it should not be happen. So the transaction is completed. Means once you got the money from the ATM machine, that means the transaction is completed, but it is not reflected into the database. So as I explained in the previous phase, log writer, what are the committed and committed changes? It's get written to the log. We can say log file here. Let's say log writer at write it commits. Means when we withdraw some 2,000 rupees, so that transaction is committed, but not database writer didn't return any changes to the data file. So means a data file consists of 5,000 software in your case. So it would not get reflected into the database. In that case, you have already withdrawn 2,000 rupees, means that your transaction is committed, and as we know that, so 2,000 withdrawal from this dribble log, so it will affected into the log files. And next time when we do restart a database, so the job of S1 is come across, so it will check in database, it will check the log file, what are the transactions committed, and that roll forward changes from the data file to the rev log file. So it will check the committed transaction and reflect into the data file. So as we know, previously we already withdraw 2,000 rupees and actual balance is 5,000. So it rolled forward the committed transaction into rev log and affect the changes into the data file. Now your database would be in a consistent state. That means you could get 3,000 as a balance over there. So that is exactly a instance recovery of made by system monitor. So that is exactly use of system monitor over there. And other task is also to roll back uncommitted transaction. Let's say other scenario, you are trying to withdraw money. It is not happening actually in a today's scenario or today's day. If we are withdrawing money from ATM machine and we could not get any ATM machine not dispense the money for us, and we are with that. In that case, if our transaction or if that get updated in database, we will be lost. Let's say I'm trying withdrawing 2,000 rupees, my balance is 5,000. In that case, so that ATM machine did not dispense money for me, and it's reflected into database, so that is a loss. So the transaction is not completed. Transaction would be completed when money is get dispensed from the ATM. So that is, we could say a transaction is completed. But in this case, I did not get any money dispensed from the ATM machine. So that transaction should not get reflected into database. So we could say that transaction should be get rolled back. But how? And at that time, light goes on the server side. So S1 roll back that uncommitted transaction. So whatever the uncommitted or uncompleted transaction in database, so S1 do that one. Okay, and it also open the database for user access. So when recoveries happen, when database is abnormally shut down, and when a database is started next time, it makes instance recovery, which make roll forward changes into the relog buffer. As I said, it can get the committed transaction from the relog buffer and relog file and make in data file, and then it roll back the transaction, committed transaction, that is means, and open the database for user access. So the database will be in consistent state. And let's say police, third point is police free space every 3 seconds. So it will be a police free space in a database buffer cache. Let's say a block is generated at the beginning, then after that one at middle, and after that one at the bottom. So next block generating would be at the last block, at the end of the last block. So there is a free space in we can say or buffer cache. In that case, so it should be freeze, or it should be the space should be get policed. Police means what? Those are allocated blocks should be arranged in a systematic manner. It should be in a sequential, and the free space should be freeze, and it get to be in a separate location. So allocated space will be in a continuous manner, and free space that will be in a continuous manner over there. So police free space means what? It allocate, it makes a free space, or it rearrange blocks allocated in continuously, and after that one free space for our database transactions will be happen. So it make a performance actually the database buffer caching. Deallocate temporary segment. So whatever the temporary segment is allocated for like sort operations and doing this one, in that case that temporary segment is going to be deallocated by S1. The PMON, the process. Process monitor. The process monitor, a background process that is responsibility is rollbacking the transaction. So transaction is incomplete, it would roll back the transaction. It release the logs. Let's say in a multi-server environment, multiple users are accessing same data, and the logs is going to be automatically handled by database. We could say, let's say, if I'm trying one table and same user trying updating on same table, and in that case both of user could not update same record, so the logs is over there, log on the table, and that logs is going to be managed by PMON, process monitor. So it release the log. There might be having sometimes how much duration that log should be on that transaction, or we can say object, and it get released according to the process monitor manage that one. And it's if abnormally database is shut down, it's release other resources. Let's say memory is used for the processes, server processes, and other processes over there. When database started, when database abnormally shut down, so memory is will be in it not get released, and next time the PMON will be released that memory. And the dispatcher, so dispatcher is required for connection, and there is a dead dispatcher, so it will get restarted. Next one, the checkpoint information is very important in database for the like recovery and this thing. So what is exactly use of checkpoints over there? It's signaling database writer at checkpoint. It make a consistency between data file and control files over there. And generally checkpoint also make database reflected in data file headers, and make record the changes related to the checkpoint in control file. A control file is important for managing database integrity and for recovery also. When checkpoints occur, it signals the database writer at a checkpoint. So when the checkpoint is occur, so the database header is going to be updated with that checkpoint information. So checkpoint does that one. Checkpoint also occurs when log switch occur. At that time, the checkpoints information get logged into control files and data file headers. So main purpose we could say in the recovery part. So it will update the data file header with checkpoint information and updating control file with the checkpoint information. So this is the main purpose of checkpoint. So the last process is archive processes. It is a optional background processes. It's generally the relog buffer. So the data changes in relog buffer is going to be written by log writer to relog files, and the main purpose is say instance recovery. But when we do have media recovery, we should have the all archive log files since the start of your database to the time of the corruption. So relog archive log file should be there. So we could do recovery at any point if database corruption is happening in data file, or any table get lost from the any data get lost from the database. We could do recovery with archive log file. So database should be in archive log mode. Then archive processes could archive the relog file when that get fulls into the archive log file. The purpose, as soon as log writer is write in cyclic fashion, when it is full, as soon as it get full, archive processes would get read that file into the relog file get written to archive log file, and that logs which occurs over there, and that whose information maintained into the control file, as we said, a checkpoint occurs on this thing. So where as soon as log file get archived, whose information goes to the control file. So it keeps information regarding everything, and this archive log file is required for recovery. That's why control file keep that information. Okay, automatically archive log file to archive automatically as soon as it get full, or should be in archive mode, and if it is not, so every time it is possible to check whether the archive log full, and so manually do archive mode. So these are very it's recommended we do have manually. In this case, we could do some database in archive log mode, and that could be done with alter systems at archive log mode and so on. So that is a different topic or different database value provider. The main purpose is to preserve the record of all changes made to the database, and everything is going to be made of that. So changes made into the database. Now this is all about the architectures and software. So that's all. Hello.
Oh, yes, Kailash.
Hello.
Yeah, Kailash.
So means I need to go to office now, right? So
Sorry?
So shall I stop there? Shall I stop them?
Yeah. So
Because of I need to go office now.
right. Okay.
Okay. So if any session is required, so we could do next time if required.
Okay. How long do you think this whole course is taken usually?
So what are the countries? If you let me know, so I'll decide that so duration and distance.
So do you have content, basic course content?
Yeah, according to Oracle University, I do have.
Okay.
But what is your recommendation and curriculum? So if you share with me, so we definitely I today work on that one.
No, in general, if you speak according to the prescribed contents, how much time does it take? 35, 40 hours?
Generally, yeah, for one module, it's 35 to 40 hours. Daily 1.5 hours, suppose.
Yeah,
so
1.5
40 to
hours.
55 hours it's required.
Okay. Okay.
Yeah. If we do 1.5 hour daily, so for one module, 40 to 45 hours is required generally.
Okay. All right, Kailash. We'll get in touch with you again then.
Okay.
Yeah. Thank you so much for the session.
Okay. Thank you.
Yeah. Have a nice day.
Thank you.
Bye-bye.